हेलो एवरीवन, गुड आफ्टरनून, गुड इवनिंग, कैसे हो आप लोग? चलो, so let's start our session and today we are going to solve PK Nag unsolved question on second law of thermodynamics. And as you all know, these questions, basically PK Nag is the best book that you can practice for GATE exam for thermodynamics. Okay, basic and applied thermodynamics, directly you will be seeing questions from PK Nag. Okay, solved or unsolved. Now solved you can do already from, because solutions are available, but let's try to solve some unsolved question in this session. In my particular, this series is going on for last 1 month. Okay, and we have solved for zeroth law, work and heat transfer, first law, and now we have moved to second law of thermodynamics. Okay, now before we move ahead in the session, let me make some few announcements. So as you all know, these are my sessions of this month, November month, free app sessions. So if you want to watch these sessions, they are already done. The last session is left for tomorrow, so you can join this. Or if you want to watch these sessions, if you are practicing for ISRO, for any other PSU or ESC exam, all the quizzes are basically of PSU level, ESC, ISRO, PSU level. Okay, so in order to watch these lectures, you need to download the app. If you are not already on the app, you can download the app by scanning this QR code, or you can just click on this link. Now this link you can directly get here. You see below this session, you will see this link, third or fourth line. You can directly click and it will take you to the app. You can download the app and you can watch all the sessions which I have taken. Okay. Also guys, if you are focusing for GATE 2025 or GATE 2026, then we have already started these classes. We have already started classes for GATE 2025 and 26. The batch have launched already, and you need to see that it is the right time to start your preparation. Otherwise, always you see, sir, now I have 1 year left, now I have 8 months left, 6 months left. So this is the correct time. You see, you at least need 12 to 13 months for your GATE exam. Okay, because at least 1 month you take for particular subject. You have around 13-14 subjects, so 13 to 14 months is perfectly required for, complete preparation without any compromise on the practice questions, on the revision, on the topics, on the subjects. And we have already started these batches from November 2023. I mean, this month we have started. Good evening, Ishwar. Good evening. Very structured course. You will have live classes, you will have access to recorded lectures, study materials will be provided, practice quizzes and mock test will also be available. You can call on this number to know more about these batches. Okay, chalo. And again, all the information is already available on the app. You can download the app by clicking on this link. Directly, all the batches, every information is already there on the app. What subjects are going on, what is the structure, everything is given there. Okay, chalo. Also guys, if you have not joined my Telegram channel, join the Telegram channel, because all my PPTs, my notes, my classes schedule, everything is updated there. So if you have not joined, join there. That is the only way you can connect with me. Okay, and I will be sending this PPT as well on the Telegram group itself. So if you have not joined, join the Telegram group. Good evening Pradeep. Chalo, start karte hain session. Let's start the session after a quick introduction. So guys, as you all know, I have 6+ years of teaching experience. I have done MTech from IIT Kharagpur. I have done MSc from Politecnico di Milano. 3.5 years of industry and research experience, few research publications, and my area of expertise is basic and applied thermodynamics and heat transfer. Chalo, I think most of you know me already. So let's start the session. Let's start the session with the very first question from PK Nag, unsolved questions. Unsolved question, ठीक है? चलो. So what is the question saying? If a refrigerator is used for heating purposes in winter so that atmosphere becomes cold body and rooms to be heated becomes hot body, how much heat would be available for heating for each kilowatt input to the driving motor. If the COP of refrigerator is 5 and the electromechanical efficiency of motor is 90%. So what it is saying? See, it is saying, sir, I have a heat pump. I have a heat pump and I am heating this room. By absorbing heat from the atmosphere. Now atmosphere is okay, and I need to provide work input. Okay. Now this work, by there will be a compressor here that I will run. There will be a compressor that I need to run through a motor. And they are saying motor efficiency is 90%. Okay. So what it is asking? Calculate the heat available for heating, यानी कि calculate this for each kilowatt. Calculate this for each kilowatt input to driving motor, यानी कि when work input is 1 kilowatt, then calculate Q1. Also, the motor that is used to run is 90% effective. So actual work is how much? Actual work how much you need to give? So see, first of all, COP of heat pump is equals to Q1 upon work input. Now COP of heat pump is not known, but COP of refrigerator is known. So what is the COP of heat pump? It is COP of refrigerator plus 1. Therefore COP of heat pump is 6. COP of heat pump is 6. Okay? So it is 6 is equals to Q1 upon work input. Now this work input should be, Hari, good evening. It should be actual work input. And what is actual work input? Ideally I am giving 1. But because motor is running at 90%, so the amount of work that is actually given is basically 1 into 0.9 is equals to 0.9 kilowatt. So actually I am able to give only 0.9 kilowatt. So Q1 is equals to 6 into 0.9 kilowatt. Now quickly tell me what is the answer. Q1, they are asking Q1. How much is the answer? 6 into 0.9. 5.4 kilowatt is the heat that is available for heating. It is the heat available for heating, यानी कि Q1. So the only new concept here is this one. Otherwise we know already everything. Yes. Chalo. Let's go to next question. Using an engine of 30% thermal efficiency to drive a refrigerator of COP of 5. यानी कि I have a heat engine. And let us say this is, I am giving Q1, this is engine, heat engine. And Q2 is rejected and W out is coming out. Now I am running a refrigerator. With it. Now refrigerator wants W input. And it will absorb heat Q3 from lower temperature T3. T1, T2, T3, T4 and Q4 will be rejected to surrounding. Now they are asking if efficiency of this engine is 30% and COP of the refrigerator is 5. and this engine is running the refrigerator. That means work input is output. Work input is equals to work output. ठीक है. Now what is the heat input into the engine? यानी कि tell me what is Q1 for each megajoule removed from the cold body of the refrigerator. यानी कि if this is 1 megajoule, calculate Q1. Calculate Q1. This is what it is asking. Next is, if the system is used as heat pump, okay, this case we will see later. This case we will see later. Let's find out Q1 first. Let's find out Q1 first. So very simple. Very simple. What do we need to do? You see, this work output are same. So when I find out this work output, I will equate them. ठीक है. चलो, efficiency of engine is equals to work output upon Q1. तो work output is equals to efficiency 0.3 into Q1. This is from this. What about COP? COP is equals to Q3 upon work input. So work input is equals to Q3 is what? 1 megajoule. 1 megajoule upon COP is 5. So it is 1.5. It is 1.5. And work input and work output is same. यानी कि 0.3 Q1 is equals to 1 upon 5 megajoule. So Q1 is equals to 1 upon 5 into 0.3 megajoule. Q1 is equals to 1 upon 5 into 3 is what? 1.8. No, 1.5, right? 1.5. 1.5 megajoule. So quickly tell me how much is Q1? How much is Q1? How much is Q1? Q1 is, let me check. Yes, it is 0.66 megajoule. ठीक है. This is the first part. Second part, if the system is used as heat pump, यानी कि instead of refrigerator, if I am using heat pump, how many megajoule of heat would be available for heating? यानी कि calculate Q4 for each megajoule of heat input. यानी कि when Q1 is 1 megajoule, then find out Q4. Find out Q4. So we all know COP of heat pump is equals to COP of refrigerator plus 1. This is 5 plus 1 is equals to 6. And also I can write it Q4 by work input. So work input is equals to Q4 by 6. Now this work input is equals to this work output. So I can write Q4 by 6 is equals to 0.3 Q1. Now Q1 they are saying 1 megajoule. For heating for 1 megajoule of, for each megajoule of heat input to the engine, यानी कि Q1 is 1 megajoule. Q1 is 1 megajoule. So write 1 megajoule here. Q4 is equals to 0.3 into 6 into 1 megajoule. तो कितना आ गया? 1.8 megajoule. Yes, 1.8 megajoule. Yes or no? आ रहा है? Yes. Very good. Let's move on to next question, third question. Okay, an electric storage battery which exchanges heat only with a constant temperature atmosphere goes through a complete cycle. Let us say this is PV diagram. Okay, so complete cycle of two process. In process 1 to 2, for example, I am going from point 1 to point 2, 2.8 kilowatt hour of electrical work flows into the battery, यानी कि work input is equals to 2.8 kilowatt hour, while 732 kilojoule of heat flows out of the atmosphere. How much Q out is? 732 kilojoule. ठीक है. Now, during process 2 to 1, now you are going back, your cycle is completed. 2 to 1 you are going. Now here, W output is happening, how much? 2.4 kilowatt hour of work flows out of the battery. Find out heat transfer in the process 2 to 1. So let me assume heat is going out. Q out is equals to this. I need to find out. Q out I need to find out. Okay, chalo. So I know for a cycle, let me write this as 1, let me write this as 1, let me write this as 2, let me write this as 2. ठीक है. For a cycle, first law of thermodynamics is Q net is equals to W net. What is Q net? Q net is, look, Q out, it is Q out, it is going out. Either you can do two things. Either you can balance Q is equals to W, or you can also do one thing. You can balance energy in is equals to energy out. Whatever you want to do, you can do. Energy in is equals to energy out. Now when you do energy in, what is going in? This is going in and everything else is going out. So work input 1 is going in. Everything else is going out. So work out 2 is going out. Q out 2 is going out. Q out 1 is going out. Everything is going out. You can also do Q net is equals to W net. But you have to take care of sign. If heat is going in, take it positive. If heat is going out, take it negative. If work is going in, take it negative. If work is going out, take it positive. You can do that as well. Same answer you will get. Okay? Now I need to find out this. So QO2 is equals to W in 1 minus WO2 minus QO1. Okay? Now you see W in is 2.8, W out is 2.4. But mind one thing. This is kilowatt hour and this is kilojoule. I need to convert this into kilojoule. So I need to multiply it. Both of them I need to multiply by 3600. I will take it common. Okay? Minus Q, this is 3732. Now tell me QO2. How much is QO2? How much is QO2? Tell me quickly QO2. By 0.4 into 3600. 0.4 into 3600 minus 732. कितना आ रहा है? How much is it? 708 kilojoule. And since it is coming positive, it means that the direction that I have assumed is correct. If it would have been negative, that means direction is opposite. ठीक है? चलो. What is the next part? If the process 1 to 2 has occurred as above. Does the first law or second law limit the maximum possible work of the process 2 to 1? And what is the maximum possible work that you can get? What is the maximum possible work that you can get? So tell me one thing. Which law limits the maximum possible work? Which law limits the maximum possible work? Conversion of one energy to another. Which law limits that? Which law limits that? First law or second law? The quality of energy. Which law limits that? First law or second law? It is the second law. It is the second law that limits the conversion of one form of energy into another form of energy. ठीक है, चलो. Now it is saying calculate the maximum possible work of process 2 to 1. Maximum possible. Now what is maximum possible? Maximum possible is, look, you are giving electrical work. Now some heat will be going out. By I have process 1 to 2, right? Process 1 to 2. Now, what is first law of thermodynamics for a process? First law of thermodynamics for a process. It is Q1 to 2 is equals to du or dE, let us say dE 1 to 2 plus work 1 to 2. Now this work is basically electrical work. So if electrical work is a high grade energy, so high grade energy can be completely converted to work. Okay, when you convert high grade energy into, but it is electrical work can be completely converted to mechanical work if you want. Okay, so this is how much? This is 732. 732 is going out. You cannot do anything with this. dE I need to find out. And you are giving how much work? You are giving 2.8 into 3600 kilojoule of work. So this work you are giving, this heat is going out, whatever energy is changing of the system, it will be converted to work. You can use that as a work. You can convert that into work. Okay. So it will be 732 minus 2.8 into 3600. Okay, थोड़ा सा यहाँ पे mistake है. What is the mistake? Mistake is this will be negative and this will also be negative. So it will be minus 372 plus this. Now tell me what is the answer. By your heat is coming out, work is going in. So take care of the signs. Okay. Now you will get how much? You will get something around 9,000, I think. सेवन नाइन तो नहीं आएगा. 2.8 into 3600 minus 732, it is 9348. So it is the energy stored inside the system during process 1 to 2, है ना? When you are going from 1 to 2, this is the energy stored. Now, it can be converted to work in the process 2 to 1. It can be converted to process into. So, if the maximum possible work were obtained in process 2 to 1. So, if this is the energy stored, inside the system during 1 to 2, then you should be able to convert that into work in the next process. You should be able to convert that into work. So what will be the heat transfer? If you are converting this much work, then what will be heat transfer? So heat transfer you can easily find out by Q223 is equals to DE 223 plus W223. W223. Now you see these are properties. Energy is a property. Energy is not going to change. Energy is not going to change if the initial and final point is same. That means it is 2 to 1, 2 to 1, sorry, 2 to 1. So if 1 to 2, yani ki 1 and 2 are same, it will remain same. It will, by it is internal energy or energy, it is the property. So it is a point function. It does not depend if you are taking 1 to 2 or 2 to 1, does not matter. Okay. So it will be minus 9348 because the direction is changed. It is 1 to 2, it is 2 to 1, but it will remain same. Okay. Plus work is how much? 2 to 1 minus 2.4 into 3600. Tell me what is the answer. Tell me what is the answer. 2.4 into 3600. Okay, it is flows out, right? It is positive. It flows out. So it is positive, not negative. Sorry. How much is the work? Heat supplied is how much? No. It is work out, na, right? It is work output. Flows out of the system of the battery. So you'll get very less value. How much is it? 708. 708 you are getting. 708. किलो जूल. ठीक है, चलो next question. A heat pump working on the Carnot cycle takes in heat from the reservoir at 5 degree. We have a heat pump working on a Carnot cycle. So let us say I have a heat pump. Working on Carnot cycle takes in heat from a reservoir at 5 degree. 5 degree is what? 277 Kelvin, and delivers is to 60. 60 is what? 333 Kelvin. The heat pump is driven by a reversible heat engine. That means I am driving it by a heat engine. At 840 degrees Celsius, 840, 278, yes, 278, thank you so much. 840 is how much? 840 plus 273 is 1113 Kelvin, and rejects heat to a reservoir at 60 degrees Celsius. The reversible heat engine also drives a machine. That means if work output is coming out here, it is driving some other machine with 30 kilowatt, and the rest is going to work input. If the heat pump extracts 17 kilojoule per second, that means if Q3 is equals to 17 kilowatt, this is Q4, this is Q1, this is Q2 heat engine. Determine the rate of heat supply from 840 degrees Celsius, यानी कि find out Q1. The rate of heat rejection to 60 degree. How much heat is rejected to 60 degree? 60 degree. Look, this is rejected to 60 degree. This is rejected to 60 degree. That means they are asking calculate Q2 plus Q4. Two things they are asking. two things they are asking. चलो let's try to find it. ठीक है. Now let's talk about engine first. So efficiency of engine is equals to W output. Okay, it is a reversible. See, it is a reversible heat engine. It is heat pump is also working on Carnot cycle. Okay. So work output by Q1 is equals to 1 minus T lower by T higher. So work output by Q1 is equals to 1 minus 333 by 1113. How much is it? How much is it efficiency? Efficiency is how much? Efficiency you are getting 333 divided by this 1 minus 0.7 Q1. Yes. ठीक है. Now let's come to this. So now COP, it is heat pump. So it will be T higher, यानी कि T4. If this is T4, let us say this is T1, T2. I always try to write it in the synchronous way. कि always I try to T1, T2, T3, T4 like this. Okay. T4 upon T4 minus T3 is equals to Q4 upon Wn. ठीक है. चलो. So now what can I do? I can write T4 is equals to 333 upon 333 minus 278. Now Q4, can I write Q4 as? Wn plus Q3 by Wn? Yes, of course I can. So if I can do that, you can find out Wn from here. ठीक है. COP 6.05. Very good. So you can find out by Q3 is what? 17. It is 17. So it is 6.05 6.05 Wn is equals to Wn plus 17. So you can find out minus Wn is equals to 17 by 5.05. कितना आएगा ये? Let me check. Are we doing it correct? Wn is how much? Yes. कितना आएगा? Wn is around 3 point something, right? Around 3 point something you will get. कितना आ रहा है ये? .36. ठीक है. Now tell me. W out. Can I write W out as W in plus .30? So it is 33.36 kilowatt. W out is 33.36 kilowatt. So I know W out here 33.36 by 0.7 is equals to Q1. So how much is Q1? So first answer you will get here. Q1 you will get. कितना आ रहा है Q1? Around 47, I think you will get, if I remember correctly. I 47, 47.66. Very good. So now Q1 is known. W out is known. Can I find out Q2? Q2 is equals to Q1 minus W out. Q1 is 47.66. W out is 33.36. How much is Q2? How much is Q2? Around 17. No, 15. 15 point something. 47 minus 33. 15. 14.3 आ रहा है. Yes. तो Q2 मिल गया. Q4 also I can calculate. Q4 is equals to Q3 plus W in, यानी कि 17 plus 3.36. So it is 20.36, and therefore Q2 plus Q4 is equals to 14.3 plus 20.36 is equals to 34 point something. कितना आएगा ये? कितना आएगा? Plus 20.36 is 34.66 kilowatt. These two things they were asking. These two things they were asking. Yes? आ गया? क्लियर है? इज इट क्लियर? $34.606 आ रहा है क्या? चलो ठीक है, आ गया, कोई दिक्कत नहीं है. चलो वेरी गुड, क्लियर है यहां तक. चलो आगे बढ़ते हैं. एक और क्वेश्चन. नेक्स्ट क्वेश्चन. अ हीट इंजन is used to drive a heat pump. The heat transfer from the heat engine and from the heat pump are used to heat the water circulating the radiator of the building. So I have, always I try to draw it like this. Look, this is my T1 heat engine and this is my T2. Q1, Q2. Now it comes out as work output. This is my heat pump, let us say. Always I write this as T3, I write this as Q3. If you always use the same signs, then most of the time you do not even need to draw the diagram as well. Okay. Now, the heat transfer from the heat engine and from the heat pump are used to heat the water circulating through the radiator. यानी कि ये जो heat transfer from the engine and from the heat pump is used to heat the radiator of a building. The efficiency of the heat engine is 27 and the COP is 4. Evaluate the ratio of heat transfer to the circulating water to the heat transfer to the heat engine. यानी कि ratio of heat transfer to the circulating water. So what is heat transfer to circulating water? Q2 plus Q4 to the heat transfer to the heat engine, यानी कि Q1. This I need to find out. This I need to find out. चलो, let's take it one by one. Okay. First of all, engine. So engine, can I say efficiency of engine is equals to work output, and work output is equals to work input. Okay. So work output upon Q1. So work output is equals to efficiency is 27%. So 0.27 Q1. So what is Q2? Q2 is Q1 minus work output. So Q2 is equals to Q1 minus work output. So it is Q1 minus 0.27 Q1 is equals to 0.83 Q1. This is my Q2. Okay. Now let's go to heat pump. So can I say COP of heat pump is equals to Q4 upon W in. So can I say Q4? COP is how much? 4. COP is 4. 4 into W in, and W in is equals to W out. W in is equals to W out. So can I write W in as 4 into 0.27 Q1? So this is how much? 0.27 into 4 is 1.08 Q1. Very good. Very simple question. So let me write it here. Q2 is 0.83 Q1 plus 1.08 Q1 upon Q1. Q1 will get cancelled. 1.08 plus 0.83. How much is it? How much is it? Okay, this I think I have guessed wrong. This is 0.73, isn't it? It is 0.73. Yes, 1 minus, I just guessed it. I thought it is correct. Yes, 0.73. Okay. And this is 1.81. 1.81. I don't, sometimes I just try to, shortcut, take a shortcut. So I just thought 1 minus 0.27 is 0.83, but it was wrong. So you do not have to do this always, because for you risk factor is very high. I can do this, I can take the risk, but you cannot take the risk. So always check. Always check in your exam. Okay. Chalo. The ratio is 1.81. Let's move ahead. ठीक है, चलो. Next question. If 20 kilojoule are added to a Carnot cycle, I have a Carnot cycle, you see, and at 100 degrees Celsius, I am adding 20 kilojoule. And rejecting 14.6 kilojoule at 0 degree Celsius. Determine the location of absolute 0 on Celsius scale. Absolute 0 on Celsius scale. Okay. Absolute 0 means 0 Kelvin. What is happening at 0 Kelvin? Okay. Now, what do you know? What do you know? What do you know? You know that for a Carnot cycle, Q1 by Q2 is equals to T1 by T2. T1 by T2. Okay. In fact, phi T1 by phi T2. And what is phi? Phi is basically a function of temperature. Okay. So let us say it is linear. Okay. So it is basically A T plus B. A T plus B. So can I say here Q1 by Q2 is equals to A T1 plus B upon A T2 plus B. ठीक है. Now Q1 is 20. This is 14.6 is equals to A into 100 plus B upon A into 0 plus B. A into 0 plus B. So what do I get here? I get here 20 upon 14.6 is equals to A by B into 100 plus 1 plus 1. So what is A by B? What is A by B? A by B is how much? It is 3.698 into 10 to the power minus 3. Okay. Now, they are saying determine the location of absolute zero on Celsius scale. Now, absolute zero is when temperature is equals to 0 Kelvin. So, heat transfer will also be 0. At 0 Kelvin, heat transfer will also be 0. At 0 Kelvin, you cannot transfer any heat. At 0 Kelvin, you cannot transfer any heat. So again, I will take any of this equation. So let us say Q1 by Q2 dash is equals to phi T1 by phi T1 dash, T2 dash, sorry. Now it is 20 and Q2 dash is 0 is equals to A into 100 plus B upon A into temperature in degrees Celsius. I need to find out, plus B. Okay. Now if you equate them, so you see this portion, when you equate them, this will get cancelled anyway. You will get what? By if the upper side is same, you will get AT plus B is equals to 0. Okay. This denominator will be equated. Okay. Chalo. So T I need to find out. A T is equals to minus B and T is equals to minus B by A. Minus B by A. No, it is, we are equating that, Baba. We are equating. We will solve it. It is not, we are not dividing it. These are two different equations. Okay. These are two different equations. We will cross multiply it. We will solve it. Okay. We are not dividing it. These are two different equations. Okay. We are not dividing it. ठीक है? Because we already knew that, you see, these factors are same. So this is equated. So we have equated this with this simply. Okay. Chalo. Now calculate, this is how much? But it is 1 upon 0.003698. Calculated is how much? 1 divided by answer. 1 divided by answer. And it is, I hope that you are able to see it. I am not hiding it. It is minus 270.3 degrees Celsius. Minus 270.3 degrees Celsius. 271. ठीक है. But we already know that around minus 273, what do we get? 0 Kelvin. So in this case also we are getting approximately same. Okay. Okay. Chalo. So this is the temperature that we need to find out in degrees Celsius. When temperature is 0 Kelvin, what is the degree Celsius temperature? We can find out using this. It is again your zeroth law of thermodynamics basically. We have used the concept of Carnot cycle with zeroth law of thermodynamics, where heat is a thermometric property and it is changing with temperature simply. Okay. Chalo. Let's go to next question. Now, a heat engine operates between the maximum and minimum temperature of 671 and 60 degree. Chalo. Again, always guys try to do it like this, okay? T1 is the higher temperature. Heat engine is this. Q1 goes here. Q2 goes here. T2 is this. So T1 is 671. 671 is how much? 944 Kelvin. This is 333 Kelvin. And it is operating at efficiency of this engine is 50% of the Carnot efficiency. Now it drives a heat pump which uses river water at 4.5. Now I am driving a heat pump that uses river water of 4.4 degrees Celsius to heat a block of flats in which the temperature is to be maintained at 21.1. So in these rooms I need to maintain temperature of T4, Q4, T3, Q3. T4 I need to maintain 21. 21 is how much? 21 is 294 I have to maintain. And river water is 4.4 yani ki 277.4. Now, assuming that the temperature difference of 11.1 degrees Celsius exists between the working fluid and the river. Working fluid 294.1 is yes, okay. Working fluid and temperature 11.1 degrees Celsius exist between working fluid and river water. That means if river water is operating at this, working fluid will be operating at lower temperature. How much lower? 11.1 lower. So it is 266 something, right? Minus 11.1. Oh, sorry, 277.4 minus 11.1 is 266.3 on one hand and the required room temperature on the other. Yani ki if you want to maintain this temperature 294 you have to maintain in the room, then you need to heat your refrigerant to higher temperature. How much higher? 294.1 plus 11.1 yani ki 305.2. 305.2. ठीक है? Now, assuming the heat pump to operate on the reverse Carnot cycle, but with a COP of 50%, yani ki COP of your heat pump is basically 50% of your ideal yani ki maximum COP. Find the heat input to the engine. Find out this per unit heat output from the heat pump. Yani ki when Q4 is 1, find out Q1. Find out Q1. Question is very long but very simple. Question is very long, looks very long, but it is very simple. Okay. How simple? See. By efficiency is equals to 0.5 for Carnot. Carnot is 1.1 minus T lower by T higher, yani ki T2 by T1. T2 by T1 is equals to work output by Q1. Work output by Q1. So it is how much? Calculate quickly. T2 is how much? T2 is 333, 944. How much is this? How much is this? How much is this? 333 divided by 944. 1 minus answer into 0.5. So it is 0.3236 Q1 is equals to W naught. Okay. Now COP is equals to 0.5. Maximum COP means T4 maximum COP is how much? You have to take maximum and minimum temperature. Okay. So maximum is 305.2 upon 305.2 minus 266.3. is equals to Q4 by work input. Q4 by work input. ठीक है. क्या हो गया हैं ऋषिकेश? क्या दिक्कत हो गई? बताओ जल्दी फटाफट, कितना आ रहा है ये? इट इज 305.2 डिवाइड बाई 305.2 minus 266.3 into 0.5. So this is 3.923 is equals to Q4. Now Q4 is how much? 1. Q4 is 1. Upon work input. Now work input is equals to 1 upon 3.923. Yes. So this work input and this work output is same. So अपना काम हो गया कैसे? Q1 into 0.3236 is equals to 1 upon 3.923. I just need to calculate Q1. That's all, nothing else. 0.7877 kilojoule per kilojoule of heat output from heat pump. .78. ठीक है, चलो बहुत बढ़िया. Very nice. Now last question is very simple. Let's finish it with the last question. I think that you may have done this already. Look, I have a reversible engine. I have two engines. Basically, one is operating at T1. This is my engine 1. Taking heat Q1, rejecting heat Q2 at temperature T. And the same heat at same temperature is given to engine 2. It is operating at T2. Now find out temperature T. Prove temperature T is the arithmetic mean of temperature T1 and T2 if engine produces, if work 1, yani ki if this is work 1 and this is work 2. If work 1 is equals to work 2, calculate that T is equals to T1 plus T2 by 2. And if efficiency 1 is equals to efficiency 2, calculate T is the geometric mean. Yani ki T is equals to under root T1 into T2. That I need to prove. Simple. Very simple. Very, very, very simple. See. Let's take efficiency 1 is equals to efficiency 2. Now what is efficiency 1? Efficiency 1 will be equal to 1 minus T upon T1. Yes, by efficiency 1 is equals to 1 minus T upon T1. And efficiency 2 is equals to 1 upon T2 by T. Yes. So I can write it here. 1 minus T upon T1 is equals to 1 minus T2 by T. This will get cancelled. T by T1 is equals to T2 by T, यानी कि T is equals to under root T1 into T2. So second part is proved. This is proved. Let's prove this part as well. W1 is equals to W2. Now what is W1? See, is equals to W1 by Q1. So can I write W1 is equals to Q1 1 minus T upon T1? Yes. From here, can I write W2 upon Q2? So it is W2 is equals to Q2 1 minus T2 by 2. So let's write it here. Let's write Q1 1 minus T upon T1 is equals to Q2 1 minus T2 by 2. Now I know one thing. For Carnot cycles, Q1 by Q2 is equals to T1 by T2. So can I write Q1? Now see, from here I can write Q1 by Q2 is equals to T1 by T. If I talk about engine 1, so Q1 by Q2 is equals to T1 by T. ठीक है? So I need to write T here. So Q1 is equals to T1 by T into Q2. So let me write it here. T1 by T Q2 upon 1 minus T by T1 is equals to Q2 1 minus T2 by T. So Q2 will get cancelled. It will be T1 by T minus 1 is equals to 1 minus T2 by T. So T1 by T plus T2 by T is equals to 1 plus 1 will be 2. Very simple. So T1 plus T2 by T is equals to 2. So T is equals to T1 plus T2 by 2. And this is your arithmetic mean. Arithmetic. This is geometric mean. So when both efficiencies are same, you will get a geometric mean. When both work are same, you will get arithmetic mean. I hope that you already knew this. Yes, I guess, because it's every time we do it, even in theory we do it. ठीक है? चलो, very good. So here we have done some good questions from unsolved PK Nag. Okay. Now next session will be of entropy. I will let you know very soon when will the next session. But on Friday I think we have, yes, on Friday we have entire thermodynamics formula revision. Entire thermodynamics. In 2 hours we will end basic thermodynamics, we will revise completely. Okay. So do not forget to attend the session Friday 6 p.m. Friday 6 p.m. formula revision, entire formula revision for ISRO. Entire formula revision for ISRO, because your exam is coming. Entire formula revision. So do join on Friday 6 p.m. Mark your calendar. This session will be updated very soon, so you will be able to see that session in your upcoming sessions. But I am telling you in advance that on Friday it will be at 6 p.m. we will have formula revision, entire formula revision. Okay, chalo. So guys, congrats to these guys. They have ESC result came out on YouTube. Here only, YouTube only. Okay. So we have so many people coming out with ESC rank. Okay. AIR 1 was gotten by Vineet Jain in CE, and in Varun Kumar AIR 9 in ME. And there were other aspirants as well. These are the toppers. Okay. So we feel very happy when our students go and get a rank in GATE or ESC or any PSU. Okay. So congratulations to these guys. Also guys, on 3rd of December. If you are targeting GATE 2025, you can sit for scholarship test on 3rd of December. And also tomorrow, 29th November, Dheeraj sir will be coming up, strategy to secure AIR under 100 in GATE 2025. Already GATE 2025 batches are started. So do not delay it, join as soon as possible, because guys, otherwise you keep asking on YouTube, you keep asking personally, you text everyone of the faculties कि sir 8 month में हो जाएगा, 6 months में हो जाएगा, 1 year में हो जाएगा. क्यों हो जाएगा? If you have time, start it right now. If you are targeting GATE 2025, okay? Because you see, the perfect time, the time requirement is basically around 12 to 14 months for the entire GATE syllabus without risking anything, because compromising anything. Okay, so this is the right time to start your GATE preparation. Ideal time, basically, I would say. Ideal time. Okay, chalo. So let's stop the session here, guys. I will see you on 6th, on Friday 6 p.m. and we will do formula revision for ISRO. Entire thermodynamics in 1.5 or 2 hours we will finish. Okay, chalo. Thank you so much, guys. I'll see you very soon. Bye bye.